This study examined the effect of high-intensity exercise on inflammatory and endocrine response in female soccer players. Blood samples were collected before exercise, immediately after exercise, and after a short recovery period to measure change in cytokines and hormones. The research wants to understand how this physiological response contributes to exercise adaptation and recovery. For problem statement, exercise is known to influence both of the immune and endocrine system. Most previous studies have focused on male athletes. There is limited information about how female soccer players respond to intense exercise. Understanding this response is important for design effective training program, improve recovery, preventing overtraining, and enhancing overall athletic performance.
Next, I will explain the methodology used in this study. This research used an experimental study designed to investigate how intense exercise affect inflammatory biomarkers and hormone level in female soccer players. The researchers measured the participant at three different time points, which is before exercise, immediately after exercise, and 15 minutes into the recovery periods. This allowed them to observe the body response exercise over time. The study involves 16 female soccer players from the Polish First Division League. The average age of the participant was 19 years and they had an average of 6.7 years of training experience. To ensure accurate and reliable results, all participants were instructed to avoid exercise, caffeine, alcohol, vitamins, and medication for 24 hours before the experiment. They also followed the same diet throughout the study to reduce the influence of external factors. After selecting the participant, the researcher conduct a graded treadmill exercise test. Each athlete start running on the treadmill at a speed of 6 kilometers per hour. Every 3 minutes, the running speed was increased by 2 kilometers per hour until the participant reached voluntary exhaustion, which means they could no longer continue running. During the exercise, several physiological variables were measured, including maximum oxygen uptake or VO2 max, heart rate, maximum power output, and pulmonary ventilation. This measurement helped the researcher evaluate each athlete's physical performance and determine how the body responds to increasing exercise intensity. To examine the body physiological response, blood samples were collected at three different time points, which is before exercise, immediately after exercise, and 15 minutes after exercise. The blood samples were analyzed to measure several inflammatory biomarkers, as you guys can see on the slide. These biomarkers indicate how the immune system responds to physical exercise. The researcher also measured important hormones such as cortisol, testosterone, growth hormone, and IGF-1 because these hormones play important role in stress response, muscle growth, and recovery after exercise. In addition, white blood cell count and blood lactate levels were measured to provide further information about the body response to intense physical activity. And finally, the researcher analyzed all the collected data using one-way ANOVA, Pearson correlation, and Spearman correlation tests. A result was considered statistically significant when the p-value was less than 0.05, indicating that the observed change were unlikely to have occurred by chance.
Now we go to the result. The study found that intense exercise significantly increased IL-6 genes expression and serum IL-6 concentration during the recovery period. Cortisol, growth hormone, HGH, and the Testosterone to the cortisol ratio also increased significantly after exercise, while IL-1 beta and TNF alpha did not show significant change. Additionally, IL-1 beta was positively associated with maximal power output. An athlete with longer training experience has lower resting IL-6 levels. These findings suggest that intense exercise produces hormonal and inflammatory responses that reflect physiological adaptation rather than excessive inflammation. Figure 1 shows cytokine concentration in blood serum of the female soccer player. Change in serum cytokine concentration before exercise, immediately after exercise, and 15 minutes into recovery. IL-6 increased significantly during recovery, whereas IL-1 beta and TNF alpha did not change significantly.
Moving to our discussion, let's first look at the healthy starting line, which represent our athlete baseline health. Before any exercise began, testing showed that the player had very low level of inflammatory genes and protein in their blood. What does this tell us? It proved that the player entered the test well rested, fully recovered, and free from any chronic stress or overtrain. They were in the ideal state to begin the physical exertion. For the point number two, but what happened once the work starts? That brings us to our second point, how exercise triggers inflammatory, specifically looking at the cytokine response. When the player intends running on the treadmill, we saw an immediate jump in the immune system marker. The most notable spike was in a cytokine called interleukin 6. Interleukin 6 acts like an energy alarm when muscle contract deeply. Players who achieve a higher maximal power output show higher level of inflammation. So, uh, simple put, the harder an athlete push their body, the higher that immediate physical stress and subsequent inflammatory response will be. Next, let's we look at the biochemical tug of war between stress and growth hormone. So, severe exercise cause a major spike on both sides on fins. One-handed, we see an increase in stress hormone like cortisol, and the other hand, we see rise in growth and recovery factor. The body elevates cortisol to unlock quick energy while simultaneously raising IGF-1 to prepare muscle for future repair. Why does the body do this simultaneously? It elevates cortisol to rapidly unlock quick energy. So finally, how do we apply this real world? What are the real world used for coach? First, because specific inflammatory marker track perfectly with an athlete work rate, coach can actually use blood tests to measure exactly how taxing a game or training season was. It takes the guesswork out of measuring load. Second, and perhaps most importantly, the majority of sports science research historical has been conducted on men. This data is crucial because it helps coach understand how female hormones and immune system unit interact. With this knowledge, support staff can design better recovery, training, and nutrition plans specifically tailored on female athletes.
Alright, to conclude this presentation, I have three key takeaways. First, performance in sport specific. Every sport is different. Badminton, sprinting, landing, all need different movement. So we can't use one test for everyone. Training must match the actual sport to improve the performance and prevent the injury. Second, environment influences outcomes. Where we test and train matters, treadmill versus field give different results. Recovery methods like oxygen also change power. Even game like training work better than drills. So the environment directly affect performance. And finally, holistic approach works best. It's not just one thing. The best result come from combining proper technique, tailored testing, and smart recovery. This way, athletes perform better, get injured less, and stay healthier overall. So, in short, to improve athlete performance and well being, our approach must be specific to the sport, consider the environment, and be holistic. That's all.